1.4 is looking at geometric series. So we're taking a geometric sequence and now we're adding it together. And that's what it says here. The sum when the terms of a geometric sequence are added together. Okay, so if we wrote the general term to get Sn, to get the sum, we'd go term 1 plus term 1r plus term 1r squared. This is like term 2 here. So to find term 2, we took term 1 times it by r. To find term 3, we took term 1 times by r times by r. That's where we get the r squared. Okay? So that's how we get the general term. To find the sum, we have two formulas we can use. It depends again what you know. If you know T1, R, and N, so if you know the first term, the common ratio, and the number of terms, we can use this formula as long as R does not equal 1. That's important. We're going to learn about, no, we're not going to learn about that. Just R cannot equal 1. Okay? And when you know the ratio term 1 and the last term, we're going to use this formula here to spit out the sum. Okay, so let's try a question. Determine the sum of a geometric series. So we have to find the sum. The first one is 12, negative 6, 3, negative 1.5. We want to know what the 11th one is. For this series, term 1 is 12. R. So to find R, we could take any term and divide it by the term before it. So we could go 3 divided by negative 6. That negative is really important. Okay, and we would get negative 1/2. So R is negative 1/2. And N is the number of terms. We want to add up the first 11. Substitute these into the formula. So because we knew T1, R, and N, T1, R, and N, we're going to use this first formula right here. So this would be something to add to your formula sheet. So the sum of the first 11 is equal to the first term times the rate, which we said was negative 1/2 or negative 0.5, to the power of n, which is 11, and then we subtract 1. So let me just look at this. Is it to the power of n minus 1? No, it's r to the n minus 1. So make sure you have that formula correctly. Okay, and on the bottom, it's the rate minus 1. So negative 0.5 minus 1. I'm going to do the bottom first. I owe you 50 cents. I owe you another $1. I owe you $1.50. On the top, okay, order of operations, BEDMAS, brackets, exponents. So we're going to try and do these brackets. Within these brackets, first of all, we have to do the exponent. Negative 0.5 to the power of 11. So we go, where's my negative sign here? Let's see if this works. Negative 0.5, there we go, to the power of 11. Okay, so we get a number. Then from that, we subtract 1. That's my brackets. Okay, and the whole thing is multiplied by 12 right there. Oops, I can't write it here. The whole thing is multiplied by 12. So then I go times 12. So I get on the top is negative 12.005, negative 12.005 and change. I'm just going to keep the number in my calculator, and I'm going to divide by negative 1.5. I'm going to go divided by negative, no, divided by, where's my plus minus sign on this thing? There he is, divided by negative 1.5. Why is this being so silly? Divided by 1.5, I bet then I go negative. There we go, divided by negative 1.5. 8.0. So if I added up those first terms, I would get about 8. Does that make sense? Looking at this, if I go 12 minus 6 plus 3 minus 1.5, yeah, that kind of makes sense that I might get around 8. Okay? The 11th term. Okay. Is approximately 8. For this geometric series for B, 2, 8, 32. Okay, so term 1 is 2. The rate, remember we take any term and divide it by the term before it. I'm going to go 8 divided by 2. 8 divided by 2 is 4. So my rate is 4, and my number of terms is 8. I'm going to substitute into the equation. Because I knew term 1, R and N, term 1, R and N, I'm going to use that same formula. So term 1 was 2. R is 4. N is 8. We already have 8 there. And on the bottom I have R minus 1, so I have 4 minus 1. So they've already simplified that. 4 to the power of 8 minus 1 I need to do. So 4 to the power of 8 minus 1. Okay, I need to times that by 2. And then I need to divide by 3. So my answer is 4,000. Oops. 4,000. Come on, 43,690. That seems huge, but let's think about this. 2 plus 8 plus 32. I keep doubling, and I'm going to keep doubling 8 times. That does make sense. Okay? Okay. This question here, we're going to be given the first term and the last term, and we need to determine the sum. So we don't know n. What I do know is the last term. I know that the last term is 5/64. I know that my first term is 10, and they already told me the rate was 1/2. What they did is they did 5 divided by 10, or 5/2 divided by 5, and they got 1/2. So we're going to use this second formula. No, we're not going to use the second formula. It says first determine the number of terms, and then we're going to sub it into a formula. Okay, so this is the general term for a geometric. Tn equals the first term Rn minus 1. So the nth term, 5/64, is equal to the first term, which we said was 10. And then we have r to the power of n minus 1. We have 1/2 to the power of n minus 1. Okay, what we do first of all is we divide both sides by 10. So we get 5 over 640 equals 1/2 to the n minus 1. To solve this, what we're going to do is we're going to rewrite, we're going to simplify 5 over 640 this. So they reduced that to 128. They said, I can divide both the top and the bottom by 5, and I'm left with 128. Well, 128 is the same as 1/2 to the 7th. And what they did, why they did that, is they knew that this base, if I have 1/2 raised to the power of something, they said, well, can I write 128 as 1/2 to the power of something? So trial and error, they said, well, 2 to the power of 7 is 128. So they rewrote that. Since these two things are equal, if the bases are equal, then the exponents must equal as well. So 7 must equal n minus 1. N has to be 6. Oh, 8. Sorry, I can't add. Okay, since there are 8 terms in this series, so now that I know n is 8, term 1 is 10, and r is 1/2, they can substitute back in. Okay, I'm going to work on more examples like this. The main key ideas you have to know from your key ideas sheet is we're going to use these two formulas, okay, depending on what information we are given, okay. It also, we are going to have to always use our general term for geometric. We always need to know that Tn is equal to term 1 r to the n minus 1. We're also going to be applying that formula as well.